Condensed spaces solids. Check your understanding. Calculate the packing efficiencies for simple cubic and body-centered cubic structures. Verify your answer by comparing them with the numbers given on page 245. So, let's solve first the simple cubic. Given, drawing of the simple cubic. Required, packing efficiency. So, the formula of packing efficiency is volume of atoms divided by volume of cell times 100%. So, to compute the packing efficiency, we need to solve first the volume of atoms and volume of cells. So, let's start. So, first one, we need to find the number of atom per unit cell. So, to solve the number of atoms per unit cell, we need the number of the center atom, but there is no center atom in simple cubic, so it's 0 plus the corner atom. So 8 times 1 over 8 is equals to 1. So 0 plus 1 is equals to 1 atom. So our number of atom per unit is equals to 1 atom. So next, let's find the volume of the atoms. So to solve the volume of atoms, we need to multiply the number of atoms to the volume of spheres. So 1 atoms times 4 over 3 pi r cube is equals to 4 over 3 pi r cube. So this is our volume of atom. So next, let's find the volume of the cell. So for example, this is the drawing of the simple cubic. So to solve the volume cell, we have a cube. So if you notice, there are 2 radius in this side, so 1 2. So let's say this 2r, and there are 3 sides, so we can put this as 2r cube. So by simplifying, our volume cell is equals to 8r cube. So now we have the volume of the atoms and volume of cell. Let's solve now the packing efficiency. So volume of atom divided by volume cell times 100%. So by substitution, we have 4 over 3 pi r cube divided by 8r cube times 100%. So both numerator and denominator has r cube, so we can cancel that, and now we have 4 over 3 pi over 8 times 100%. So 4 over 3 times pi is equals to 4.19 divided by 8 times 100. So our packing efficiency is equals to 52.38% or 52%. So it means that 52% of this is actually atoms, and the rest is space. So next, let's solve the body-centered cubic. Given, drawing of the body-centered cubic. Required, packing efficiency. So again, this is the formula of the packing efficiency, this one. So now let's solve first the number of the atoms per unit cell. So again, to solve the number of the atoms per unit cell, we need the center atom. So in body-centered cubic, we have 1 center atom. So let's put 1 plus the corner atom. So we have 8 corner atoms times 2, 1, 8 is equals to 1. So 1 plus 1 is equals to 2 atoms. So the number of atoms per unit is equals to 2 atoms. So next, let's find the volume of the atoms. So to solve the volume of atoms, we need to multiply the number of atoms to the volume of sphere. So 2 atoms times 4 over 3 pi r cube is equals to 8 over 3 pi r cube. So this is our volume of atom. So next, let's find the volume of the cell. So for example, again, this is the drawing of the body-centered cubic. So sorry for my drawing. So volume of cell is equals to A cube. So how? So let's say this side, we have A, and A. So we can put this as A squared plus A squared plus A squared. So this is a Pythagorean theorem, but we put A since they are all has the same length. So it equals the to 4 arc squared since it has 4 radius, 1, 2, 3, and 4. And sorry for my drawing. So let's simplify this. So a squared plus a squared plus a squared is equals to 3a squared. We have invisible one here. And by simplifying this one, we can have 16r squared. So divide both sides by 3. And have a squared is equals to 16r squared over 3. And 2 and square both side. So we can have a is equals to square root of 16 r squared over 3. But since 16 and r squared is perfect square, we can simplify this 2 and we can have a is equals to 4r over square root of 3. So our volume of cell is 4r is equals to square root of 3 raised to 3, since volume of cell has always the cube. So since we have the volume of the atom and volume of the cell, we can now compute the packing efficiency. So again, volume of atom and over volume of cell times 100%. So by substitution, we have 8 over 3 pi r cube divided by 4r over square root of 3 cube. So let's simplify this first. We can have 64 over 3 square root of 3 r cube. Then let's solve this. Both numerator and denominator has r cube, so we can cancel these two, and let's proceed to 8 divided by 3 times pi is equals to 8.378, and 64 divided by 3 square root of 3 is equals to 12.317. So times 100%. So 8.378 divided by 12.317 times 100% is equals to 68.02% or 68%. So body-centered cubic is more efficient than simple cubic, which calculated with 52% packing efficiency. So the simple cubic is the most inefficient of the packing method for spheres since it's only have 52% packing efficient.